Okay, use the minus theorem to find in polar form the 5 roots of z to the power 5 equals 1. Choose one of the roots w where w is not equal to 1. Prove that w squared plus w cubed is real. So what we're going to do is we're going to first of all move over we're going to change this into 1 plus 0y. So we're going to find out what is the polar form of 1 plus 0y. 1 plus 0y, as we well know, is just 1 to the right. This angle here is 0 degrees and the r value equals 1 because it's 1 in length. So remember, the polar form is r cos theta plus I sin theta. Okay, it's going to be 1. It's going to be cos 0 plus I sin 0. Now we got to add in our 360 degree rotations to account for rotations that also have an r equal 1 value. Okay, so we're going to add this 360n to each one. So it's going to be plus 360n, and this angle here is going to be plus 360n. Therefore it's going to become cos 360n plus I sin 360n. Now, once we're done with that, it goes find in polar form the 5 roots of this equation here. Okay, so the 5 roots of this equation. So what we're going to have next is we're going to have z to the power 5 equals this in polar form, which is going to be cos 360n plus I sin 360n. So power 5 z, when you bring the 5th over to your side, it's going the 5 over to your side is going to be 360n plus I sin 360n. This is all to the power of a 5th. You multiply a 5th by each angle, and you're going to get z equals cos 72n, because 360 divided by 5 is 72, plus I sin 72n. Now, once you've done that, what you're going to do next is going to start off with n equals 0. You find out what n0 is. n0 equals cos 0 plus I sin 0, and that equals 1. Z1 equals where n is equal to 1, so it's going to be cos 72 plus I sin 72. Z2, I want it in polar form, excuse me. Keep it in polar form this time, then we're going to have cos 144 plus I sin 144. It wants 5 roots, so Z3, therefore it's going to be cos 216 plus I sin 216. And then we're going to have it plus another 72, it's going to be cos 288 plus I sin 288. Now there's our roots there. Now what it wants us to do next is choose one of the roots w and prove that w squared plus w cubed is real. So what I'll do is I'll choose the second root, or z1. I want to prove that z squared plus z cubed equals a real number. So what we're going to have here is cos 72 plus I sin 72 to the power 2 plus cos 72 plus I sin 72 to the power 3. What you're going to do is use the minus theorem, multiply the angle by the power, and you're going to get cos 144 plus I sin 144 plus cos 216 plus I sin 216. Now what I'm going to do next is I'm going to add the two of these together using the calculator. So we're going to have is cos 144 plus cos 216 What we get there is minus 1.618. Then the next one we're going to have is sine 134 plus sine 216. We get there is 0. So we can see that this here is a real number because it just has a real part and no imaginary part. Now, if 1, W1, W2, W3, W4 are the roots of z squared equals 1, calculate the sum of cos 2m pi over 5 plus I sine 2m pi over 5. Alright, so this is a fancy way now, a really fancy way of doing what we've already done. So an example would be, these are the roots, okay? This one here is z0. We already did that earlier, that z0 is 1 plus 0i. Okay? And then that's going to be, this one here is w1, this one's w2, this one here is w3, and the last one there will be, that's w4. Okay? So, oh wait, sorry, it's not including the first one, excuse me. So let's try this again. This one here, W1, W2, W3, W4. Okay? And what I also want is, if I was to decode this language here, okay, 2 pi is 360, and 360 divided by 5 is 72. So, and then it's going to be I. So it's basically asking you what is the sum of, when you do it like this, n equals 0 to 4, and it wants cos 72, because 2 pi in radians is 360. 360 divided by 5 is 72m plus I sine 72. So what it wants me to do is it wants me to add them all together, because we've already done this already, and we already have all the numbers. So it wants me to start off at n equals 0, and remember, n equals 0, n equals 1, n equals 2, n equals 3, and the final part is n equals 4. Remember, that totals up 5 roots. So this is a fancy way of saying sigma means add all 5 roots together. So what we're going to do is we're going to add all 5 roots together. So we're just going to use all of this here and add it all together. So what we're going to do first and foremost is we're going to add all the real parts together. So what we're going to do is we're just going to add all these downwards. Okay. So we're going to get is cos 0 plus cos 72 plus cos 144 plus cos 144 plus cos 216 plus cos 288, and what we're going to get here is 0. So the sum of all these are 0. Then we're going to add all the sines together, like so. And when we add all the sines together, what we're going to get, sine 0 plus sine 72 plus sine 144 plus sine 216 plus sine 288, and once again 0. So we're going to say the grand total of all them added together equals 0. Okay. Write this in the form, polar form, okay? So what we're going to do is we're going to draw it out first. Now I'm going to multiply it in first. I'm going to get minus 2 plus 2 root 3i. Minus 2 is 2 to the left, plus 2 root 3 is 2 root 3 up. And what we have here is this complex number here, which is located here. Now what we have here is 2 root 3 and 2. we're going to find out the angle x. Once we find out the angle x, then we can find out the angle from the starting off point. So tan x equals 2 root 3 over 2. X equals tan inverse 2 root 3 all over 2, which gets me 60 degrees. This here is 60 degrees. Take it away from 180 and you get that is 120. So theta ends up to be 120 degrees. Now we need to figure out the length or the modulus value. So remember, r equals the square root of real squared plus imaginary squared, which is going to be it's going to be minus 2 squared plus 2 root 3 squared. Put that into the calculator, we're going to get a square root of 16, which ends up to be 4. Now let's change this all into the right form here. Okay, so we're going to have 4, it's going to be cos 120 plus I sine 120. Okay, and once all that's done, what we're going to be doing next, using the Myers theorem, find two values of this here. Okay, so the Myers theorem. Now, what we can see from the question is that this complex number in here, that this complex number in here, by underline it, is the same complex number as this one here, is the same as this one here. So find two values would mean z squared, because there's two different answers. Two values would mean z equals, and we're going to put this whole thing for cos 120. Now we're going to put in the angle to 360n to account for the rotations, plus I sine 120 plus 360n. And what it wants us to do is to do this to the power of 3 over 2. So what we got to do is we got to multiply each angle by 3 over 2. Same thing here. And then put 4 to the power of 3 over 2 in front. Now 4 to the power of 3 over 2 in your calculator is 8. And then it's going to be 8 cos, now this here is going to be multiplied by 1.5. So that's going to be 180 plus 540n plus I sine 180 plus 540n, close bracket. Now we're going to find out what z0 and z1 are, because we want two different values. So z0 is 8 into cos 720, 1820 plus that is 720, because n equals 0. Oh sorry, excuse me, n equals 0 is just cos 180, excuse me, plus I sine 180. Okay, and now what we're going to get is z0 equals 8 cos 180. 8 cos 180, 8 multiplied by cos 180 is going to be minus 8. 8 sine 180 is 0, so it's going to be minus 8 plus 0i, which is minus 8. Then we're going to have z1. Z1 means replace n with 1, so it's going to be 180 plus 540, which is going to be cos 720 plus I sine 720. Once again, in your calculator, just enter in what 8 720 is. So 8 cos 720, you can see that that's 8. Okay, so no worries there. Z1 equals 8, and then sine 720. What we get there is 0. So we have in the next question is question 12. Express minus 27 in the form r cos theta r sin theta. So once again, I'm just going to draw the plane. Minus 27 is located over here. Okay, and we know that this angle here is going to be 180 degrees. So we know that our new value is going to be 27 cos 180 plus I sine 180 degrees. Okay, so that's that part done there. Now, use the Myers theorem to find the three roots of the equation z cubed equals z squared cubed plus 27 equals 0. That's the same thing as z cubed equals minus 27. Now, we know that minus 27 equals this. We also have to account for the rotations, okay? So what we're going to say is that z cubed equals 27, okay, and then it's going to be cos, and we're going to do 180 plus 360n, because we got taken the other answers, plus I sine 180 plus 360n. Okay, next thing we're going to do is bring over the 3, and when we bring over the 3 over the other side, what's going to do is going to put the full thing to the power of a third. Now, when you have this thing to the power of a third, it's going to be 27 to the power of a third, and 27 to the power of a third is 3 when you put it in the calculator. So it's going to be 3, and then we're going to have to multiply each angle by a third. So a third of 180 is 60, so it's going to be 3 cos 60 plus 120n plus I sine 60 plus 120n. Okay, next thing we're going to do is find out our, we have 3 roots. So what we're going to do next is we're going to find out what each root is. Z0 is going to be 3 cos 60 plus I sine 60, and then Z1 is going to be 3 cos 60 plus 120 multiplied by 1, because n equals 1. It's going to be cos 180 plus I sine 180. Then we're going to have Z2. Z2 equals 3 cos, now this one's going to be 2 times n is 240. 240 plus 60 is 300. Cos 300 plus I sine 300. Okay, put these into the calculator and find out is that the first one equals minus 3 plus 0i, which is still minus 3. Second one, Z2, is going to be 3 over 2. 3 over 2 plus sorry guys, excuse me, just got these mixed up here. This one here, excuse me. This one here is minus 3 plus 0i. This one here is 3 over 2 plus 3 root 3 over 2i. Once you put it into the calculator, 3 cos 60 first, and then 3 sin 60 second. The last one's 3 cos 300, which is once again going to be 3 over 2, and then 3 sin 300 is going to be minus 3 root 3 all over 2i. So there's our 3 answers there. Now what they go next is, when plotted on an arcane diagram, the 3 roots line the curve. Find the equation of this curve. Okay, so find the equation of this curve. So what happens is you're going to draw the 3 points on the diagram on an arcane diagram, okay? So this one here is minus 3, 0, which is basically 3 to the left, and it's located here. The other one is 3 over 2, 3 root 3 over 2. So you go across 1.5, and then you go up and you plot this one here. Okay, and then finally Z3 is 3 over 2 again, minus 3 root 3 over 2y, so you go around this far down and you plot this one here. Then all of a sudden what you notice is that if you draw a circle from the beginning, you notice that they all fit on the same circle. So it is in fact a circle. Okay, now it goes find the equation of this curve. Well, to find the equation of this curve, what we realize is that they all sit on a circle. Okay, so what we get here is we're going to get x squared. The equation of a circle is x squared plus y squared equals r squared. That's the equation which has centre 0, 0. R equals 3, so the equation is going to be x squared plus y squared equals 9. Okay, so that's what we have for us. X squared plus y squared equals 9. Okay, now what's going to ask me next after that is draw this curve and plot the 3 roots on the curve. Already done. Verify that the 3 roots form an equilateral triangle. Now, to form an equilateral triangle, I would join these together, and what would need to happen is that an equilateral triangle, either everything would be 60 degrees when you have an equilateral triangle, or all the lengths would be the same. So what I'm thinking about doing here is I'm thinking about doing the distance formula to each one. So I can say the distance formula to each one is going to be so for example the distance of the length of Z1 to Z2. Okay, so the distance of Z1 to Z2 is going to be the square root. Now remember, it's x2 minus x1, so it's going to be root 3 over 2 minus root 3 over 2 squared plus minus 3 root 3 over 2 minus 3 root 3 over 2 squared. Now the distance of Z2 to Z3, we call that x1, y1 again this time, and it's going to be equal to the square root of x2, which is 3 over 2 minus 3 squared plus y2, which is minus 3 root 3 over 2 minus 0 squared. And finally the distance of Z1 to Z2. And this time I'll change this one to be x2, y2. So what we can get here is it's going to be minus 3 over 2 squared plus 0 minus 3 root 3 over 2 squared. So what I'll do next is come in with the calculator and do this out. So it's going to be the square root. Now 3 over 2 minus 3 over 2 is 0 squared, and then we're going to have plus, minus 3 root 3 minus another 3 root 3. So we'll just enter it all in. So we're going to have bracket minus 3 root 3 all over 2 minus 3 root 3. Oop. Gotta get rid of that part there, I'm afraid. 3 root 3 all over 2, and then we square that. Now there's a syntax error here, which means that the square root sign, we can see it here, isn't expanding all the way over. So we try and fix that now. So you can see the square root sign didn't go all the way over, so we try this again. So square root of 0 squared plus bracket 3 root 3 all over 2 squared. Oh sorry, it's all in one bracket. So we go in here again, minus bracket 3 root 3 all over 2, and the first one is a minus 3 root 3, so we just got to fix that there. Then what we're going to get is the answer is 3 root 3, so that's 3 root 3 right there. Then we try another one, just change it around. So this time it's going to be 3 over 2. It's going to be 3 over 2 minus 3 for the squared sign. this time I'll just square root the answer afterwards, right? So I'm just going to do what's in the bracket first and then square root the answer. Okay, so we're going to get 3 over 2 minus 3 squared. So with that, I'm going to get 117 over 4. I'm going to square root the answer. I'm going to get 3 root 13 over 2. Sorry guys, the first one is Z1, Z3, excuse me. So Z1, Z3. Second one Z2, Z3, and third one Z1, Z2. Okay, so this one here should be a minus 3, which gives us plus 3. Okay. So what we should have got here would be 4.5. So 1.5 plus 3 is 4.5. 4.5 squared plus bracket 3 root 3 over 2. Over 2 squared, we get is 27. Now the square root of 27, there we go, is 3 root 3. So that answer matches the second one. Okay, and we're hoping the third one will also be 3 root 3. So let's find out. So we're going to get minus 3 minus 3 over 2 equals, we're going to square this answer. We get 81 over 4, and then we're going to plus, it's going to be 0 minus 3 root 3. Three all over 2, and then we're going to square that, and then once you square that you get 27. Square root your full answer, and that one is also 3 root 3. Okay, so that's the answer for question 12. Now finally question 15, I probably won't have time to do.